Then consider the islands of the Marquesas in French Polynesia, a group of high volcanic islands, a hotspot volcanic chain rising from a steep-sided ridge. For all their celebrated boldness in profile, the islands of the Marquesas are falling to pieces. They are surrounded by an apron of sediment derived from the erosion of the islands themselves. The volume of material in that apron is 240,000 cubic kilometers, and the volume of the volcanic islands themselves, from 4 kilometers depth, is a mere 50,000 cubic kilometers. Evidently, far more of the islands of the Marquesas lies as debris scattered around their bases than remains in the islands themselves. The corollary to this startling observation is that to produce the volume of material in the modern debris apron, the islands of the Marquesas must have had to build themselves up, then waste away, then build themselves up again, then waste away again, and so on. Large-scale flank collapse through landsliding is a normal and expected part of the history of an oceanic island. It is well established that younger, particularly volcanic islands, have steeper sides that are more prone to landsliding than older islands, whose flanks have become gentler over time as a result of landsliding and other processes of mass wasting. Yet age is not the only guide to the relative vulnerability of islands to flank collapse. Many islands, despite being comparatively old, still maintain steep sides that are as liable to collapse as those of younger islands. Such islands are found along much of the Hawaiian Ridge, which has the steepest underwater slopes of any emerged oceanic structure on Earth, and elsewhere, particularly where uplift rather than subsidence is occurring. One of the largest landslides to have occurred in a single event during the history of the Hawaiian Ridge is the Nu'uanu Slide, which occurred about 2.1 million years ago off the northeastern coast of Oahu Island, and involved the movement of an estimated 5,000 cubic kilometers of material. It is inferred that this slide took place at high speed, perhaps 80 meters per second, because some large blocks were moved down the ridge flanks and then 350 meters up the other side of the submarine moat that surrounds the Hawaiian Ridge. The Nu'uanu Slide produced waves 50 to 60 meters high that washed across Oahu and nearby Molokai Island, and sent a tsunami across the Pacific that was about 20 meters high when it reached the land in the northeastern part of its continental rim, Alaska to California. The youngest landslide off the west side of Hawaii Island, the Big Island, may have happened during the coldest time of the last ice age, around 22,000 to 18,000 years ago, but more likely around 100,000 years ago. Known as the Alika Slide, it involved movement of as much as 2,000 cubic kilometers of material downslope in 2 major phases.